All right, Integrated Math 3, this is your answers video for lesson 4.01 at long last. It says it's due Monday, April the 19th. It's past that date already as I'm recording this. Go ahead, you can turn it in, try to turn it in Friday, which will be April the 23rd, okay, and get this assignment. It's not a real long assignment, and we've done most of the problems in class, all right? But I'll give you a few extra days for that. Okay, let's go ahead and get started. So, you just want to become familiar with each of these principles. The best way to do it is just to work problems rather than just talk about them. But these are the principles that deal with logs and with exponentials. So what are we talking about with an exponential? So an exponential is an equation or an expression, but an equation here where the exponent is a variable. So if you said x squared, that's not an exponential. The variable is the base of that number, and then it's raised to the second power. This is an exponential because it has a variable in the exponent there. So this is exponential form. A logarithm is simply an exponent. So if you took this same expression, the way you convert it to logarithm form, the way I think about it is down here. To convert an exponential to a logarithm, you take the base here, and you write the word log and you make that the base. So this is called the base. A here is the base, whether or not it's in this form or this form. It's called the base. And then this is the exponent here in exponential form, so you simply write it over there. So really x is, what really a logarithm produces is an exponent. And this is called the argument, it's the y. So here's the way to view this, is that a raised to the x power equals y. So when you look at logarithm form, what you're saying is, what would you have to raise this base a to get this number y? And the answer would be x. That would be the exponent that you have to raise a to. The x is the exponent you'd have to raise a to in order to get y. So the way to convert between the two, I just think of, you make this base small and put it after the word log, and then you switch the other two. The y comes over to this side and the x goes over to that side. So I call it big guy small and switch the other two. So the big guy here gets smaller with the word log, and then you switch the x and the y. Going in the other direction, you make the base big, and then you switch these two, the x and the y. So it becomes a to the x power equals y. All right, so now why do we use logarithms? And I showed you in class, what logarithms do is two things. If you are to plot this going from 0 to 5, then the numbers you'd put in for x would be 0 to 5. The values you'd get from y would be anywhere from 1 to 100,000. You couldn't possibly plot this function on a piece of graph paper, because as x went from 0 to 5, this number would go from 1 to 100,000. That's just too big a range of numbers. It's too big of, their numbers are too spread out, going from a small number like 1 to a very big number like 100,000. So that's one thing. It basically scales everything down. If you were to do this, the log of that, and you were to plug in x, what you'd end up with is x goes from 0 to 5, y would go from 0 to 5. And so that makes it something that's much easier to graph. And that's one of the reasons we do it. Also, this produces a curved graph. If you were to graph this, it's a curved graph. Whereas if you graph a logarithm, it's not a curved graph. So let's go ahead and just do some of these and work through these, okay? Okay, since I'm late getting this up, I'm going to go ahead and do all of these with you, but I want you to see where you do get these from. So what you do is you use this as your reference. What you do is you just go through each of these principles until you find the one that would apply to the problem back here that you're trying to do. So 3 to the first power. So this very first principle says that any number raised to the first power is itself. That means 3 to the first power would equal 3. 0 to the first power would equal 0. That's all there is to that. Just understand that raising something to the first power just produces that number. Okay, what about 2a? 8 to the 0 power. So we come over here. I actually didn't put that one on this table here, but anything raised to the 0 power is 1. Whoops, there it is. I'm sorry, I did put it there. I thought I just missed it. So any number raised to the 0 power equals 1. The exception is if a is equal to 0. 0 raised to the 0 power is undefined. You can't, it just doesn't exist. Okay, why that is, you don't need to understand. It just doesn't exist. Okay, so I'm going to come over here, and 8 to the 0 power equals 1. A to the 0 power, it doesn't matter what a is, it equals 1. And 0 to the 0 power, we said, is undefined. It doesn't exist. All right. What I want you to do here is I want you to go ahead and verify that this is equal to 2. So a to the x times a to the y equals a to the x plus y. So that's what that is the form of this. 2 to the second times 2 to the third will equal 2 to the 2 plus 3. What I want you to do is verify that. So 2 squared is 4. 2 to the third is 8. 4 times 8 equals 32. 2 to the 2 plus 3 equals 2 to the 5th. And 2 to the 5th is 2 times 2 times 2 times 2 times 2. That also equals 32. All right, let's go ahead and do this one. So a to the 0 equals 1. We said that up here. And 3 to the first equals 3. So this, no matter what a is going to equal 3. All right, a times 2 to the 4th. Well, 2 to the 4th is 2 times 2 times 2 times 2. That's 16. And 16 times a, you can't simplify that any further, so it's just 16a. All right, how about this? 4 squared times 4 to the third. Let's do that. So 4 squared is 16 times 4 to the third is 64. And when we multiply those together, we get 1024. So verify that by doing this. Now 4 raised to the 2 plus 3, and that equals 4 raised to the 5th. So on this calculator I can say 4 and caret, that means exponent, 5, and that's going to equal 1024. So they both equal the same thing. In a number of these problems, I want you to just verify that 2 different versions of the same equation will give you the same answer. Okay, so you get the same answer there and there. All right. Now, a raised to the third and then raised to the 4th. So let's find the principle that applies to that. It's this one right here. A raised to the x and then raised to the y equals a to the x times y. Let's go ahead and come up here. So a to the x times y, that's 3 times 4, equals a to the 12th power. So let's verify this. Well, that's what it equals. We'll verify it when we come over here with an actual number. So there's the answer to that, okay? It's a to the 12th. So let's verify it here. 2 squared is 4 to the 4th power. Okay, and 4 to the 4th power, 4 times 4 times 4 times 4 equals 256. Okay, so is that the same as 2 to the 2 times 4? Well, that would equal 2 to the 8th. And if you go to your calculator and punch that in, you'll also get 256. So in other words, raising 2 to this power and then taking that number, 4, and raising it to this power will give you a number. That's the same as 2 raised to these two numbers multiplied together, 2 times 4. All right, how about this one? A to the 4 raised to the 5th, and that's simply going to be a to the 4 times 5, which equals a to the 20th power. Okay. All right. A to the 4th divided by a to the 3rd. So this principle is this one right here, a to the x divided by a to the y equals a to the x minus y. So this is going to be equal to a to the 4 minus 3, which equals a to the first. And if you want, you could just write a equals a. All right, 4 minus 3. Okay, a to the 3 minus 7. So be careful on these. The double negatives can mess you up here. So this is equal to a to the 3 minus, and then negative 7. So you have a double negative there. So this becomes a plus. So it's equal to a to the 3 plus 7. And that's a to the 10th power. And that's the answer there. Okay, finally this one. And you got a to the minus 2 minus negative 6. So that's equal to a to the negative 2, and the double negative becomes a positive 6. And negative 2 plus 6, or it's easier to think of it as 6 minus 2, is a to the 4th. Okay. All right, and that's the answer for that one. Okay, this one's pretty straightforward. You can factor out the x to the 4th here. And by the way, it's this principle right here, number 6. B times a to the x plus c times a to the x. You can factor out the a to the x. That's something you've done before. All right. So we're going to pull out the a to the 4th, and what you leave behind is the 2 plus the 5 here. Again, if you multiply this, you get 2x to the 4th. If you multiply this, you get 5x to the 4th. So that's 7 right there. So your final answer is 7x to the 4th. You put the coefficient out in front like that. All right, same thing for this one. Put parentheses around this. You're going to factor out the x to the 5th. Inside you have 5 minus 3. That equals 2, so you put 2x to the 5th. You just swap places there, and you got 2x to the 5th. Okay, next up. Okay, we're going to look at this principle down here, that a to the minus x equals 1 over a to the x. So you simply you flip the sign. If it's a negative up here, you flip it to a positive. If that was a positive, you flip it to a negative. And then you just put the entire thing over or underneath 1. You take the reciprocal of it. Okay. All right, so this one I just wrote it. It's just an example there. You're good with that. Okay, so this is going to equal 1 over 2 to the positive 3, and 2 to the 3rd is 8, so it's going to equal 1 over 8. How about this one? Well, you're going to change the sign to a positive 2, but that's going to bring it up to the top. It flips. If it's on the bottom, it goes to the top. If it's on the top, it goes to the bottom. So this simply equals 4 squared, and that equals 16. So this equals 16. All right, here what we're going to use is the inverse property of logs and exponents. And it's this one down here. And it says if you have a number up in a variable up in an exponent, how do you get that number out? How do you figure out what that x is? 10 raised to what power gives you 3? How do you figure that out? That's not something that comes to mind just naturally what that 3 would be. So what you need to do is get the x out of that exponent there and just make it an x down here somewhere, just like a regular x. So how do you do that? The way you do that is you take the inverse. If you have 10 to the x and then you take the log of that number, 10 to the x, it gives you x. So it basically unwraps the x. It gets it out of that exponent and just makes it a regular variable like that. Okay? So let's go ahead and do that. We have 10 to the x, so what we can do is take log 10 to the x. Okay? So the log and the 10 are inverses. They reverse each other. And that just leaves you with the x down here. It's not an exponent anymore. It's just a regular variable now. Now you can do that. You can stick the log there like that as long as you do it to the other side. That's the basic rule of math. Anything you do to one side, you do to the other. So that means you have to take log of 3. So if I have 10 to the x equals 3, then log of 10 raised to the x equals log of 3. I put log on both sides, so it's legal to do that. So now you would get your calculator, and just go to the log button. I know it's a little blurry here. Hopefully you can see it. So I hit, turn it on first, I hit log, and I hit 3, close the parenthesis. There you go, and that gives you 0.48. So log of 10 to the x is x, and log of 3 is 0.48, and that's your answer. And one way you can test that is raise 10 to the 0.48 power and see if it gives you 3. But let's see if that works. So we're going to take 10, and the little caret is the exponent, that right there, and it's to the 0.48 power, and we're going to hit equal, and it gives us 3.02. It's a little bit of a rounding error, okay? It was actually 0.48 something, 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 so that's okay. So it's close enough, all right? And all I was doing was checking. So it came close enough to 3 that we would count that. Okay, 8b and 8c are the ones that I said were probably the hardest problems, so I'm going to do both of these for you. So you're going to use the inverse property here, but what you have to recognize is the parts of this equation here. So this is the base, this is the exponent, and that's the answer. So in this case, 2 is the base. That's your base there. If you're going to inverse that, you can't inverse it with a log base 10. If you just write the word log, it implies that there's a little 10 there, that it's a base 10. You can't inverse a base 2 with a base 10. So what you have to do is you have to take log base 2. So log without any base there means it's base 10. But if you do put a log, something other than 10 there, then you can do that, and that's legal. I mean, that's just the way log works. So it's log base 2. So we're going to take log of base 2 of 2 to the x. And that's going to equal, now anything we do to this side we can do to the other, so that's going to equal log base 2 of 9. Okay, I just took log base 2 of both sides. Anything I did to one side I can do to the other. Okay, over here, so log of base 2 of 2 to the x, the log base 2 and the 2 are going to inverse each other. They have to be the same number there. So that means this side's just going to be an x. That's great. That was easy. But this side's not so easy because we don't have a function on our calculator to do base 2 log. A base 2 log. So we can't figure this out on the calculator this way. So there's a really neat formula with logarithms called the change of base. And it's this one right here. It says the log of any base x, that's why we use a variable there. It could be any base x with an argument, this big, the y is called the argument, with argument y equals the log of any base that you want it to be. You get to pick it. Any base b of y, this big number, over log of any base b, you get to pick that, but it's got to be the same number there, of x there. Well, the base you want to always pick when you do this is 10 because your calculator does log of base 10. That's the operation it does. So in other words, compare this with how we write this. Log base 2 of 9 is going to be, we're going to write that as log base 10. Now you don't have to write the 10. If you don't write the 10, it means it's log of base 10, but I'm going to write it just to emphasize that that's the b that we picked, the base. And then that's of the big number on top over log of base 10. And it's of this little base here, too. Okay? So we have a way to calculate that. So this is just simply log of 9. This is simply log of 2. So you take those, you divide them, and you got your answer. So here I'll come here. Try to focus it here. So log of 9, close the parenthesis, that gives us 0.95, so I'm going to write that here, over log base 2. So I'm going to come back here, log 2, close the parenthesis, and that gives you 0.3, 0.3. Okay. And when I do that division, 0.95 divided by 0.3, I get 0.32. So that's my value of x here. That's my final answer. Whoops, I take that back. I'm sorry, 9.5 divided by 3, my bad. 9.5 divided by 0.3 equals 3.17. Sorry about that. I hit the wrong key. So that's your final answer. This divided by this is 3.17. That's your final answer. Okay, so let's test it. You can test by plugging this in for x. So 2 raised to the power of 3.17, and that equals 9.00. That's exactly 9, so that's what it should be. Okay, so again, you use the change of base formula for that. The same is going to be true for this one. See if you can do this one before you watch me do it. I am going to do all of them on this assignment. Okay, and I'm going to try to get as much space as I can. So all of that space is for this problem. Okay, so what did we have to do? We had to get this x out by taking the inverse here, by doing an inverse. So 3 raised to the x. So what we're going to do is take log of base 3 of 3 to the x. And that's going to equal log of base 3 of 2. So what the log of base 3 and this 3 do is they cancel each other out. They're inverses of each other. Again, we're using this principle right here, right there. Log of base 10 of 10. So to inverse the 10, it has to be log of base 10, which that is. When you don't write anything, it is 10. So the log and the 10 inverse each other, so all you end up with is the x. But in these last two problems, that wasn't a 10 there. It was some other number. So in this case, it's a 3. So that means we have to use log of base 3, and then to inverse a 3 here. So that means that's going to become just x right there. So this one just becomes x, and this one becomes log base 3, 2. Now we have to use the change of base, see if you can remember it, to figure out this side. So it's going to be log of any base we want, and we always want to pick base 10. And then on the top goes the bigger number, this one right here. On the bottom, it's also log of base 10. We get to choose that, and these two have to be the same. You wouldn't want them to be anything other than 10 anyway. And that's going to be of the smaller number here is 3. So we can come over here, log of 2. Just do that on your calculator. Log 2 is 0.3. And log of 3, try to keep the glare off, log of 3, close the parenthesis, gives us 0.48. And when we divide those two, 0.3 divided by 0.48, that gives us 0.63, and that's our final answer. Again, the way you can check it is go ahead, if that's the value of x. So 3 to the 0.63 should equal 2. So let's see if it does. 3 caret 0.63 equals 2.0. So that's what you got, exactly that. Okay, by plugging that in for x, you could check your work that way. All right, so that's how you do those. Those are the most complicated problems on this assignment. Okay.